Good evening, everybody. Welcome to the December Astro Talk. Last one for the year, just before Christmas. Welcome everybody who's here and welcome to everybody who is at home. We have a lovely talk this evening by the former ASA president, Kim Thessalonidis. Did I say that right, Kim? Yeah, okay. Close enough? Close enough. I'm not very good with those. Not very good with long names. Before I introduce Kim, I just want to do a little bit of housekeeping. We have our live stream, which was meant to be on Sunday, Festivus for the rest of us. Weather wasn't too great and we had some technical issues, so we've rescheduled that to the 20th of December from 9:30 p.m. That'll be a live stream where we're going to live stream deep sky objects, probably, no, not the moon, but deep sky objects, maybe some planets, so nebula, galaxies, star clusters and the like. It's a bit of a Christmas celebration for everybody who wasn't able to get to the star party for the Christmas barbecue, which was clear at night. So we're going to do that. And then I think it's the first weekend after the New Year. So from the 3rd and 4th of Jan, we're up at Mount Buller holding some public viewings up there. The information will be on the website from probably tomorrow, I would say. So that's just a few things that are happening over the summer period. You also have a public viewing night out in Hamilton on the 18th of January as well. So if you're out in the regional areas, get out to Hamilton on the 18th, come and see us down at Mitchell Park. Well, there's some telescopes out there. Now I'm going to introduce Kim. Kim is the former president of the Astronomical Society of South Australia. Did a good job of it as well. He enjoys a lifelong passion for astronomy and space with several interests, including astronomy outreach. Kim joined us at Sea Lake last year and did some great outreach with some of the students that came along from, I'm not sure what school it was. It was a school that came along. Castlemaine Steiner School it was, and Kim spent the whole evening with them, showing them how to live stack data. It was very good. Electronically assisted astronomy and supernova photometry. Since January 2000, Kim has published the Evening Sky Map. Highly recommend you go and download that. It's a great document. Each month at skymaps.com to help tens of thousands, I'd say hundreds of thousands, Kim, since 2000. It's been going for millions? Millions, okay, millions. Millions of sky watchers worldwide discover the wonders of the universe. As I said, Kim is a past president of ASA and prior to retirement was employed for 30 years as a rocket propulsion scientist, where he led a team of scientists, engineers and technicians. I'm going to ask you some questions about that afterwards, Kim. So Kim is going to talk tonight on the largest single object in the night sky and two craters of the moon named Colin Stanley Gum, named after Colin Stanley Gum. A few other objects, I'm assuming, as well. Yeah, yeah. Who is a prominent Australian astronomer. I'm not sure what you were trying to say there, Kim. No. Yet few people know the story of the young astronomer who spent his early years in the Southern Flinders Ranges before graduating from University of Adelaide and later with a PhD in astronomy from the Australian National University. Despite personal challenges throughout his short life, Gum completed several impressive studies in both optical and radio astronomy, including a photographic survey of hydrogen emission nebulae in the Southern Milky Way, which revealed the spiral structure of our home galaxy. So Kim's going to talk to us tonight about that. When Kim's finished, we're going to have Bill Stant, the telescope gent, join us for What's in the Sky. But for now, Kim, the floor is yours.
Thank you. Hopefully people can hear me. Am I on? I'm on, okay. Well, thanks for turning out tonight. I know it can be difficult getting, I'll be told it's quite difficult getting a park around here in certain events. Anyhow, I'll be talking about Colin Stanley Gum. I'm just wondering how many in the audience may have heard of Colin Stanley Gum before. There's 1, 2, 3, 4, 4, 5, 6, okay. All right, well, you're going to learn a lot more about Colin Gum during this presentation, perhaps more than you want to know. But it's a fascinating story, and the reason I'm being given this talk is because, obviously, if you look at the date up there, it's the 100th anniversary of his birth. And he's very much an astronomer that really isn't well known in Australia, especially amongst the public. All right, so let's get started. So just quickly an overview. I'll be talking a little bit about his family life, his early education, university studies, a number of personal challenges he faced, the research he conducted at Mount Stromlo and at the Radiophysics Laboratory. I'll run a short video showing some of the nebulae that carry his name. This video is composed of photographs taken by members of the Astronomical Society of South Australia, NASA, and I'll make some concluding remarks right at the end. So, as I said a moment ago, we're celebrating the centenary of Colin Stanley Gum in 2024, and the ASSA newsletter, monthly newsletter, actually had a really nice article in colour talking about Colin and showing some of the objects and describing them, including the visual observation of gum objects in the Vela, in the constellation of Vela. So that was really good. But starting where it all started, Colin was actually born on the 4th of June 1924 that is, in Adelaide, in what was called a maternity hospital, and a number of these smaller hospitals around Adelaide at the time. This one no longer exists. In fact, I don't think any of them exist. But it was in just on South Terrace, which is within the 1 square mile of Adelaide. His father was a farmer. He was born in Nairn, which is a farming area just east of Adelaide. And his mother was born in Adelaide as well. This is a very South Australian Adelaide story, by the way, if you haven't picked up on that yet. So they were married in March of 23, and they were both from what's called the mid-north of South Australia. I'm going to show a map of that shortly. However, his father died. He was quite ill, and he died about a month before his son was born. Right? So a month before Colin was born, his father passed away. He had been a member of the Australian Imperial Force, had gone to war, the First World War at the time, and on his way to the UK on the ship, he became very, very ill. And by the time he got to the UK, he developed pneumonia, and then he came down with anemia, and he never really recovered, and eventually passed away literally 4 weeks before his son was born. Very sad. So Colin was born on the 4th of June, I mentioned that earlier, and thankfully mother and child were both well. So just get a sense of where the mid-north in South Australia is. It's shown there in orange. It's north of Adelaide, 200 to 200 kilometres plus north of Adelaide. And it's quite a large area, mainly farming area, wine as well. But the parent, they were a farming community where he lived. So after about 5 years, his mother remarried someone from Gladstone, which is also in the mid-north. And what happened was they had another 2 kids. Milton, who I believe went on to become a Methodist minister. A lot of the information, I'll rephrase that. Some of the information in this presentation is not particularly solid. I haven't been able to nail it down. There's still lots of new information out there that I haven't been able to get my hands on. But we believe he was a Methodist minister in New Zealand. He married Faye Gale, who had quite a high profile in Adelaide in the academic area in cultural geography and Australian Indigenous studies, but they eventually divorced. And his other son, their other son was Alan, and he had a distinguished career as an allergist at the Royal Adelaide Hospital and also in the Children's Hospital. In fact, he introduced the use of Ventolin for the treatment of asthma in South Australia. And he also used to put out pollen counts every day on the radio so that people would tune into and get a sense of how the conditions were likely to affect them. He married Shirley Ann Gale, and she's still with us. She's an organist at St. Peter's Cathedral, which is that huge cathedral near the centre of Adelaide. So she's still with us. All right, so this is one of the earliest photos I have of the lads, the boys, and Colin is the guy in the middle, and his younger brother to the left of this image, and his older brother, the older brother of the 2 new half-brothers is on the right. Obviously colourised and obviously a montage as well. So in terms of primary and high school education, he went to Gladstone Primary School and clearly did really well there. Was awarded several times. was one of the more successful kids at the school. He also went on to high school in Gladstone, which is, again, I mentioned, in the mid-north, was Dux in 1937, and eventually awarded a Prince Alfred College scholarship, which is one of the premier private schools in Adelaide. And this was supported by the Repatriation Commission that looked after the needs of returned servicemen and their families. So at PAC, he was there for a few years as a day boy. He wasn't boarding. At that time, he lived in Torrensville, which is an inner western suburb of Adelaide. And again, he did really well in 1939, 40, passed with honours in 1941, and eventually matriculated in 1942. So he went off to university, and there's a bit of uncertainty as to how and where he started, but eventually ended up at the University of Adelaide. He may have started off in the School of Mines, but was doing essentially a civil engineering degree at this time, as best as I can work out. He'd also moved to Nailsworth, or what's now known as Nailsworth. It was known as Prospect Gardens at the time. It's literally across the road from where I live. Adelaide is such a small place, Everyone kind of knows everyone else, but anyhow. In any case, again, he did really well. First year at university, getting credits, passes. And then at the end of the year, end of 1942, he enlisted, felt the need to enlist for military service. Now, why he did that, who knows? His father had served in the AIF during the First World War, and that had not ended well. The war in the Pacific had obviously escalated in the preceding 12 months. Australians were now enlisting in very large numbers. And the Prince Alfred College newsletter was advocating enlistment at the time as well. Do brave deeds and endure. But anyhow, it meant we got the first ever high quality photograph of Colin. This is the day he went and enlisted for military service in Adelaide. And he was assigned as a trainee radio operator and posted to Shepparton recruitment depot in Victoria. Curiously, if you look up the National Archives, they have his aptitude test results there. And I'm sure no one wants their aptitude test displayed in public, right? But you look at this and you go, hang on, this guy's a really smart guy. He's done really well in primary school, high school, university. Numerically, fair. General intelligence, below average. Speed and accuracy, not there. Capacity for planning, design, nah, not really average, below average. Mechanical aptitude, way off the scale almost. Some of this just does not gel with his academic results over several years. So I can't make sense of this. I can't really reconcile this, but that was what was published. What was it? What's online? Anyhow, off to Shepparton to do some training, and that's what this looked like. These photos were taken around the time he was there, maybe a couple of weeks or so around the time he was there. A lot of climbing, a lot of jumping, and a lot of running around with sharp blades at the end of rifles and doing things like that. So he enlisted on the 11th of December. On the 16th of December, he was listed as a casualty. Discharge was recommended 2 days later, and his condition was deemed satisfactory by about 3 weeks after that. Now, what exactly happened to him? We don't have access to medical records through the National Archives, but through some of the paperwork online, you can see he went in quite healthy, but as they got him out of the service, he had clearly suffered significant lower abdomen trauma requiring surgery, etc. So he had some pretty serious things going on with him, and it obviously took a while for it to settle down and be declared safe. This is in training, right? A few weeks later, his discharge was finally approved, and he resumed his university studies in March the same year. So, yeah, all I can say is the description of some of the injuries are clearly this guy suffered a lot of trauma at the time and would have had to live through that for the rest of his life. So, resuming university studies, he's not the same guy, okay? When getting passes, fails, lots of fails. He's not having fun at all over 3 years, right? It ain't working for him anymore. But he did sign up to the older Conservatorium of Music. Started attending in 43, the year he resumed his studies. This is the music conservatorium that's actually in the University of Adelaide grounds, for those of you that know where it is. He was awarded actually an orchestral scholarship, flute, and that was running for 3 years. So what happened then? He transferred to a Bachelor of Science degree. So he got out of the civil engineering side and got into the science. And things turned around for him. And he was able to sort of get through all of that after a few years and then passed even physics honours. And eventually a degree of Bachelor of Science honours was conferred upon him in 1949. But what happened in 1949, there are absolutely no records I've been able to find. Not sure what happened then, but if you join the dots, he got into astronomy somehow. I don't know how, but through that year, he was already doing astronomical research with Mount Stromlo. That's what's become clear. And the reason that's clear is when he actually put in for a Master of Science project and got that approved, and it was on the topic of photoelectric observations of 3 southern stars. And during the course of that work, early on, he actually changed the title because it became apparent that he discovered that one of the stars was actually a variable star, and actually a spectroscopic eclipsing variable star. So the title got extended to this topic. So, and it has this star varies in magnitude by 0.1. Apparently it's quite a well-known variable star that amateur astronomers track these days. Varies over 1.2 days, but only varies by about 0.1 magnitude. So measuring binary star orbits at the time, we're talking in the very early 50s, was actually critical to determining the mass of stars and other properties of stars. So he moved to the Commonwealth Observatory at Mount Stromlo to conduct these observations under the mentorship of Dr. Hogg and colleagues. Remember that name, Dr. Hogg. Don't forget the name. And he also was appointed Secretary of the Canberra Orchestral Society. So the music stayed with him, right? So he kept going with that. A year later, he's presenting his Master of Science thesis. Pretty sure he was working on this in 1949, actually. You'll find out why in a moment. And it was awarded to him a few months later. So he got his Master of Science from the University of Adelaide. Didn't attend. He was still busy at Mount Stromlo doing his work on his next project, by the sounds of it. So what was he doing with these photometric observations? Well, the star was variable. He discovered that and was measuring it photometrically along with some other spectroscopic binaries. He used the 9-inch Oddie refractor, which should be well known to members, some members, I hope, of the Astronomical Society of Victoria, particularly the folks in Ballarat, right? And there's a really good documentary that the ABC made about the James Oddie and his donation of this telescope. And so that's worth finding on YouTube. It was done by the ABC not so long ago. A really nice documentary on it. So he used this 9-inch refractor. He did a total of 326 observations during that 49-50 observing season. And each observation required 5 measurements. And a lot of those he had to throw out as well. So he was busy, flat out busy, doing all these measurements and got the work done within a year or maybe a year and a half. And he had to make some corrections, and the paper discussing his results and the analysis is actually published in Royal Astronomical Society, and you can download a copy. But this is one of the graphs out of it, and it basically shows the results of his hard work to do photometric observations and plot all this data out. And this is the observatory at which the work was done. This is the Oddie Dome, very famous building, no longer exists, burnt to a crisp in 2003 during a firestorm up at Mount Stromlo. And apparently, if it's true, I think this is true, this is the first building ever commissioned by the Commonwealth Government of Australia when Federation started. And it was set up at Mount Stromlo, and the whole purpose of the building was to put that refractor in there to measure the atmospheric conditions to determine if Mount Stromlo was a suitable site for an observatory. So a very famous building, and the 4 bits sticking out the side were all the individual rooms where astronomers would sit and do their work. And the telescope was in the middle there. Yeah, but it was actually a very important building because it did a lot of that early work on trying to look at stars, estimate their age, their size, their chemical composition, etc. That spectroscopic work was really important back in the 50s to understand the universe. All right, so the first big project Gum was actually involved in was actually a radio astronomy project. It was actually an all-sky survey in the 200 megahertz range. And he did the work with Alan. Now, Alan is actually really well known. He's an Australian astronomer out of Perth. He's the author of a well-known compendium called Astrophysical Quantities. That was first published in 1955 and is still in print. I think most astronomers have that book on their desks somewhere. So he conducted the work with Alan, and it was done at Mount Stromlo. They used a really crude antenna, but that was one of the first all-sky radio surveys ever produced. And despite the low resolution, it was actually, the data was not superseded for many years. And it basically showed the radio noise radiation in the Milky Way and the major concentration at the galactic centre. And this is what it looked like. And there's a big white blob there. That's where you couldn't see below the horizon. But what you have there is basically the Milky Way and the radiation from the Milky Way in the radio part of the spectrum. And this was it. This was the first all-sky radio image that was produced. And it wasn't, as I said, it wasn't superseded for many years. So his next project was really his PhD. And this is a photographic survey of what's known as H2 regions in the Southern Milky Way. Basically, he was looking at emission nebulae to identify emission nebulae in the plane of the galaxy to identify the shape and structure of our Milky Way galaxy. That was the aim of the work. So again, this work was initiated by Alan, but he left in 1951 and became professor at University College in London, and leaving Gum to actually do the work, which he took to very quickly. So he obtained most of his observations at Mount Stromlo and a few at the Flinders Ranges as well. And he used slit spectra from the nebula spectrograph to confirm some of the very, very faint regions. He produced a catalogue of 85 hydrogen emission regions. 40 were completely new. And that included the discovery of the large H2 region in Vela Puppis, now known as the Gum Nebula. Right, and he published this in 1955 with all these regions. 85 of them, 40 of them were new. And I'll just show you how he went about doing this. This is quite innovative. So, so he was using the spectrograph and the Schmidt camera. The camera had a field of about 11 degrees or 10 degrees, say. In 1952, there seemed to be a lot of fires out at Mount Stromlo, don't they? Another fire damaged the spectrograph, but the Schmidt camera was salvaged, repaired, and the survey continued just with direct photography. So he was photographing the night sky with this small camera. So what he did was these are the days before Photoshop, people. So there's nothing digital here. He's using film and he's using filters. So he took one shot of about 35 minutes and he was trying to image hydrogen alpha, which is a narrow part of the spectrum. He used a particular film to do that, the 103AE, and he used a particular filter which had a bandwidth of, I'll convert that to modern terms, it's 25 nanometers, which again is really crude. Any astrophotographers here would know that you really want something around 6 nanometers, 3 nanometers is fantastic. You can afford those filters. He was using 25, it was pretty crude. So he would photograph H alpha, hydrogen alpha, 35 minutes and did it at f1.7. So he had a 100 millimeter aperture, which is a 4-inch diameter lens, but he would stop that down to 60 millimeters. I think that's the numbers. Probably because he was getting some aberration effects around the perimeter and he needed to overlap these images across the sky. So he had to stop it down. So instead of shooting at f1, where he would have shorter exposure times, he's now shooting at 35 minutes at f1.7. He then would take another shot called the comparison shot using another film, a different filter now to avoid the nebula lines, emission lines. So he doesn't want H alpha on this one, shooting that for 50 minutes, right, with the same bit of kit. So 2 exposures are required to make one observation. And they're taking about an hour and a half to do the 2. And he then went further, and this is what he did. So he takes a H alpha photo. This is a scan from one of his publications. He takes the regular photo, He then adds the negative of the regular photo to the positive of the first one. And what he's trying to do here is neutralize the stars, make the stars and all the star fields, as you're looking into the band of the Milky Way, there's a lot of stars there. He's trying to get rid of the stars so you can see the nebula. All right, and the nebula comes up as a dark patch that's shown in that third frame. This is the equivalent today of what I think is called continuum background subtraction. And you'll often see the astrophotographers take photos of nebulae, remove the stars, and suddenly you see a lot more nebula. He's doing this on film and glass filters, right, and stacking them in the lab afterwards. Right, really, really tedious stuff. Anyone recognise what that nebula is, by the way? It's a trick question. That is a commonly photographed nebula. Well, maybe. No? What is it? No? No. Actually, it's a bit of a trick question. Maybe it's not that common. No. All right, I'll put it up here. Well, no, I'll put it up next. Sorry, I jumped ahead. So he would then actually sketch that out. He'd look at that print. He'd then sketch it out and highlight with the cross-hatching the really dense parts, the lines by less dense, and then dots with less dense. You can see the pattern there. He's actually he would draw these out by hand. And that's it there. And now the question is, anyone recognise that nebula? No. Okay, the answer is no. It's actually the Fighting Dragons of Ara, NGC 6188, right? And there's a photo of it there. You look at it, you look at those two last frames, you can actually see he's done a reasonably good job at that, right? And that is really quite a faint object, right? So anyhow, I'll show some more of these photos. And he's actually captured the egg as well. See the dragon's egg here? It's over here. And it's over here, I think, in the H alpha. So he did quite amazingly well. And this is his original sketch of the Gum Nebula. This is a really large nebula that he discovered. It spans about 30 to 40 degrees, maybe more now in the sky, between Gamma Velorum and Zeta Puppis, which are the two stars. And if you take a photograph, and this is what he did to get the Gum Nebula. There's 18 individual shots there of two shots each, I suspect, H alpha and the comparison shot. And you can see it, 18 shots were taken to actually identify this thing. So that's 18 times by an hour and a half. So he was doing a lot of work here. So from that, he derived the drawings. And this is a photo taken by one of our members, our current president of the ASA, Gerhard. And this is a photo of the Gum Nebula. And if you superimpose his sketch on top of that, you get this result. And I'll just flick between the two, and you'll just see how that's a pretty amazing job at drawing this out, given that no one had actually seen this previously. And he's pulled it out of those 18 shots, right? And yeah, the really bright bits, he's really identified those really quite nicely, and a lot of the fainter bits. A remarkable job, right? And this is another photo of the Gum Nebula, and in black and white now. And if you map that same drawing over the top, again, you get the original body, you get the arc on the side as well. Again, did a remarkable job back then to actually pick this up out of the sky. So this nebula, the Gum Nebula, is actually an emission nebula. It spans about 36 degrees. I think it's much larger than that. It's ionised by the UV radiation from two nearby stars. At least that is the theory. The two stars are the two stars you see here, Gamma Velorum and Zeta Puppis, the two stars there. They're the ones that are thought to be ionising that gas cloud and making it glow. It's the largest emission nebula in the sky, but it's got a very low surface brightness, which is why it went undiscovered until 1952. Estimated to be about 1,000 light years across versus the Orion Nebula, which most people are familiar with. They're known about 24 light years. Distances from us is 450 to 1,500 light years, so it's like a big bubble in space. It's been long speculated that it's actually a supernova remnant, but it contains star-forming cometary globules that are consistent with star-forming regions in nebulae, in molecular clouds, not supernovae. Nevertheless, I think the final decision is not out. It's not available on this nebula. And nearby you'll see the green Vela supernova remnant as well. That's been around for about 11,000 years. I think that went off then. So the Gum Nebula has generated a lot of interest over the years. There's been a symposium that's been run. You can download that. That was back in 1979. It's 250 pages of people talking about the Gum Nebula. And then the Apollo 16 mission to the moon, actually, there was a science project on that mission to actually investigate the Gum Nebula. And the way that was conducted was they waited for the module to come as it was returning to Earth when it was in behind the moon. So when it was positioned, so the moon was between the sun and the Earth, so there was no light falling onto the spacecraft. They had a mission to go and try to photograph the Gum Nebula, right? In pitch, really, really dark conditions, right? I think failure is probably understating what they actually achieved. Unfortunately, it's probably the worst photo I've ever seen of the Gum Nebula. There's no sign of it, no trace of the Gum Nebula, but even lots of star trails. They had a go, couldn't actually pick it up. And I've never seen a final report on it. There's one photo and it smacks of failure, unfortunately. But they had a go. It was really quite an object of considerable interest after it was discovered. Yeah. They used a Nikon format camera. It wasn't a Hasselblad, no. It was a Nikon. If you go to the report, they used just a Nikon. Actually, I'm going to drop some names now. One of the guys, I didn't find this out until later, one of the guys on that, one of the Apollo astronauts on that flight was actually a guy I met earlier this year. That's Charlie Duke. He was at Stamos in Bratislava in May this year. And if he's at the next one at La Palma in April next year, I might just quiz him a bit more about this, see if there's an inside story. But I don't know, I'm sure he's forgotten it all now. But no, it was very unsuccessful, unfortunately. All right, so now we have a bit of a crisis going on. He suffered a nervous breakdown in 1953. His workload was through the roof. You probably gathered that from his photoelectric measurements that he did initially, and then all the photos he's taken of all these nebulae in the sky and the process he's applying to that. His workload was through the roof. He was actually in a race against Bart Bok at the time. Now, Bart Bok had this massive profile in the US and elsewhere. It was on TV every other night promoting astronomy, the Milky Way. It was Mr. Milky Way. And he was in a race against him to sort of complete this work and do it from the southern hemisphere because the northern hemisphere had been sort of mapped out already quite well. But no one was really doing the southern hemisphere, and Bart, I think, might have been in South Africa at the time trying to get some data to complete the database on the structure of the Milky Way, where the spiral arms were. So he suffered quite a bit of stress and sort of had a breakdown, and it was even suggested that he periodically suffered from mental health issues from his colleagues. His thesis was submitted in June '54, and it got worse from there. Initially, the thesis was rejected by the examiners, the initial set of examiners. Ben Gascoigne actually helped him make some minor changes to the thesis, and they were really minor things. If you go and look at his PhD thesis, there's a page at the front where they talk about the changes. Really minor stuff. They found another examiner, and he gave a really enthusiastic report on the work, and he got his PhD degree. It seemed a bit silly at the time. But anyhow, Bart Bok did go on to say that Gum had set the standard for conducting these surveys of the Southern Milky Way for others to follow, others being himself, by the way. And I think the RCW catalogue is one that's maybe more familiar to amateur astronomers. You'll see RCW against various objects, etc., from time to time. Well, again, these are Australians, and they did this work, but they used an 8-inch, used exactly the same methodology that Gum had developed, but used an 8-inch camera instead of a 4-inch camera now. Much higher fidelity images, ran at f1, and they ended up producing a much larger catalogue as a result as well. And again, you can download their paper. So in 1955, I was really surprised to learn that Colin Stanley Gum was a guest speaker at an ASA general meeting. Really surprised to learn that. He was actually living in Adelaide, back in Adelaide at the time, working as a physics demonstrator at the University of Adelaide. And his topic was the spiral structure of the galaxy. And yeah, so the meeting was held at what's known as the Institute buildings on the corner of North Terrace and Kinto Avenue in town. A number of visitors attended, but what really came out of the meeting that I liked was a really good copy of the minutes of what was spoken about. And I'm actually going to take a couple of minutes to read the minutes because it actually captures really well the intent of his research. And what surprised me is how many things have not changed since 1955 and a couple of things that have changed. But this is a fascinating and really well written up description of his research and its significance. So the speaker began by explaining that although we know the shape of distant galaxies, we are unable to see the shape of our own galaxy, the Milky Way, because we are inside it, being some 27,000 light years from the centre of a galaxy estimated at 100,000 light years in diameter and in the central plane of that galaxy. Pretty spot on so far, nothing's changed there. Observations of hydrogen nebulae found in the spiral arms of the Andromeda Nebula. They still hadn't got into the habit of calling the Andromeda galaxy a galaxy. They're still referring to it as a nebula. This is what, 30 or so years after Edwin Hubble has done his work, showing it's not part of our galaxy. It's not a nebula, it's something else, it's a galaxy. Okay, so led us to believe that most of the hydrogen regions in our own galaxy are to be found in the spiral arms. So looking at other galaxies, seeing where the hydrogen alpha is, the nebulae, and saying, well, most in our galaxy, surely we're the same. So we must find these hydrogens, must find this hydrogen alpha. Therefore, the study of these regions in H2 nebulae within our own galaxy would reveal the direction and shape of the spiral arms to us. Stars within the area of H2 gas regions cause that H2 to light up. That's the fluorescence, permitting us to detect the H2 areas by their fluorescence. I'm getting ahead of myself. Seen by us as nebulae. Most of these dense regions occur in the plane of the Milky Way, as would be expected. Large regions, however, occur some 20 degrees away from the central plane of the galaxy in Orion, Puppis, and Ophiuchus, and here is referring to the Gum Nebula. Dust clouds obscure our vision in looking towards the centre of the galaxy and along the arms, but we can photograph nearby regions, and from the portion of the arms thus plotted, we can get some idea of their shape and direction. Using various colour techniques and by constructing composite photos in which the star images are neutralised and the shape of the H2 regions given prominence, we can produce photos showing the H2 regions. Much of this work has resulted in the discovery of new H2 regions. He discovered an extra 40 of them that weren't previously known. A diagram thus plotted gives a definite result showing the structure of portion of our spiral arms. I'm reading this verbatim at the moment. Radio means are used to measure H2 gas radiation, or H2 continually emits a radiation that can only be received by radio receivers. Unlike optical observation, which is limited to the fluorescence of the H2 lit by the stars, radio observation can map all the H2 regions and see through the obscuring dust clouds. Both optical and radio observations agree, and distances are roughly correct, enabling us to map the spiral structure of the Milky Way near to us. The plotted arms converge towards the centre of a circle formed by galactic rotation. Mr. Gum showed a photo of M51, the Whirlpool Nebula, again, it's a galaxy, and compared it to the results of the research on our galaxy. The spiral arms and various offshoots and fins from the arms were explained. Mr. Gum illustrated his talk by several slides of nebulae and exhibited enlargements of photos taken by the Schmidt camera used in his work. The camera, a 4-inch f1 telescope, was exhibited and promptly dismantled by the members. Okay, it took circular photos about 1 inch in diameter, equivalent to 10 degrees of sky, etc., etc. So there you have a really nice summary of his work and the significance of it and why it was important at the time to actually help explain this, to inform the structure of the galaxy, our galaxy. So a few months later, or actually a few weeks later, PhD ceremony. His degree was conferred And it's believed to have been the first PhD in astronomy from ANU, Australian National University. And if you look carefully, he'll turn around and look at you. Oh, there you go. There you go. Don't blink. All right. So, and then shortly thereafter, a few months, he was actually elected as a Fellow of the Royal Astronomical Society, which is quite a prestigious position. He was then appointed as a research officer at the Radiophysics Laboratory at CSIRO in June 56, and again to investigate the spiral structure of the Southern Milky Way from radio observations. He's done the optical work, he's done the nebulae, got ahead of the game there, particularly in the southern sky. Now he's doing more radio work and correlating the two. He was quickly put on this subcommission by the International Astronomical Union for defining a new galactic coordinate system. And he used basically basic maths and applied least squares solutions to determine the best position of this plane. He was actually probably one of the best people on the planet to do this, having done the hydrogen emission work and radio work, even from the 200 megahertz study. He actually had data, he knew what he was talking about, he knew about where all the good stuff was, and basically brought that all together using different assumptions. And he's actually responsible for having calculated the galactic coordinate system that is still in use today, which is amazing. There was an old one, and it was refined with the work that he did under that commission. He co-authored 3 of the papers that were published in the monthly notices on this project. Unfortunately, they were published in 1960. And against his name, there is an asterisk. And if you read the footnote, it says deceased. So he never actually got to see that published. He was very fortunate also around that time to actually be awarded a Carnegie Fellowship to study astronomy at Mount Wilson, well, in Pasadena at Mount Wilson and Palomar Observatories. And this was made available by the philanthropist Andrew Carnegie, probably the richest person on the planet at the time. Yeah, he wasted no time flying out of Sydney. He got on a plane, and it was actually the first commercial flight of a jet aircraft across the Pacific. He was on a Qantas flight, city of Canberra, and 707. And again, you can go on YouTube and find the video of this big event. First ever commercial jet aircraft flying from Sydney to the US, right? And it was quite a big event in the day. The guys from the radiophysics lab came down to farewell him, and he'd already been hushed away because of all the ceremonies associated with the big event. They never got to see him. He wrote back to them apologising for his hasty departure, but he had no choice. Unfortunately, it was also the last time he stepped in Australia. Right? That was it. He never came back. But again, while he was working as part of the fellowship, he was fascinated with the structure of the galaxies and using polarization effects. He quickly embarked on a visit across America and met up with Gerard Kuiper, this is the Kuiper Belt fame guy, met up with other people doing photometry and working on galactic structures, and went to a meeting, American Astronomical Society meeting in Canada as well. In January 1960, he received an offer for a senior lectureship at the School of Physics at the University of Sydney. He notified the boss, Dr. Pawsey, at Radiophysics, and he wrote to him again a few weeks later saying, really quite sorry I'm going to do this, but a university position gives him something he really wanted. And he was basically going to make the jump over to the university from the radiophysics lab work at CSIRO. But he was planning a quick trip to Europe lasting 3 weeks in order to talk with telescope manufacturers, because they were keen to actually acquire and build a very large telescope as part of Sydney University. He officially notified his resignation in March of 1960 and said he was sorry not to be returning. His association with the RP has been an extremely happy one. He feels that the position in the new astronomy school at the university is just what he wanted. And he's glad he'll be near radiophysics, and it will be a pleasure to renew acquaintances of both personal and scientific reasons. And off he went. He was always ahead of the game, and he went to Europe to work on the telescope, and that's basically when tragedy struck. He perished on the 28th of April of that year, 1960, aged 35, in a skiing accident at Zermatt. And that's the Matterhorn there, by the way. So the newspapers reported at the time he was killed when he fell over a precipice. He left the normal route and fell onto rocks. Colleagues sometime later think he possibly failed to understand the warning signs, which are in German and French. There is a plaque and a sundial at Enfield Memorial Park, and that's how I stumbled across Colin Gum many years ago. And there's a plaque there with his name, and it's next to the plaque of his mother and his stepfather. So Bart Bock's obituary notice was published in the RAS as well, and it reads, Colin was one of the best liked and most admired of younger Australian astronomers, and many of us have a deep sense of personal loss at his too early death. Australia's still very short of first-class astronomers trained and educated in the country, and his death is a severe blow to the development of Australian astronomy. He'll be remembered for many years to come for his successful search for and discovery of hydrogen emission regions of the Southern Milky Way. The large and significant complexity of nebulosity in Puppis and Vela is generally referred to as Gum's Nebula. A finer monument is difficult to imagine. For a person of his age, Colin leaves behind a solid and impressive bibliography of significant contributions, and in spite of his too early death, he has left his permanent mark on the development of astronomy. And this is what we're talking about. He has a place in the sky. This is a fantastic photograph. This won the Skyscapes category of the Astronomy Photographer of the Year 2024. And that big red thing in the middle there is the Gum Nebula. It's huge. Very difficult to, well, I don't think you can see it visually, and very difficult to photograph as well. So this photograph was taken by Tom Ray. He's a 19-year-old, I think he's a New Zealander, and you can follow him on Instagram. That's his handle there, TXMRay. Give him a follow. His photographs are absolutely stunning, right? But this one in particular won him the award this year, and that was quite timely. A place on the moon. Lunar features are only named after deceased scientists and explorers of high and enduring international standing. The IAU has a sign name since 1919. You've got to be deceased for 3 years. Military and religious figures are not eligible. And just to be on the safe side, politicians must be deceased for at least 200 years. Right? And I think so far that rule has worked. I don't think we've got any danger there. However, there are only 5 Australians honoured in this way. And by Australians here, I mean people who are actually born in Australia. You find people like Douglas Mawson, who people think of as Australian. He wasn't actually born in Australia. So these are 5 Australians who were born in the country are named in this way, are honoured in this way. John Tebbit, very famous guy. Howard Florey, inventor of penicillin, right? Creator of that. Arthur Hogg, remember that guy I mentioned early on? The guy who did the photoelectric measurements with Gum? He's on there, he's on the moon. So is Pawsey, the guy who came to the airport to farewell him. Left him behind, but he was quite prominent, very prominent in radio astronomy, radio physics. And Colin, and that's it. They're the 5 Australians on the moon. Right? And if you want to find Colin on the moon, he's parked behind the parking lot. And you have to rely upon vibration, the rotation of the moon at certain times of the year and the month for his crater to appear over the limb. Most of the time it's out of sight. But the moon wobbles backwards and forwards ever so much. You have to wait till it's in the right position. You use a program like Sky Safari to actually find suitable dates and go out there and try to see it, which is probably easier than photographing it, actually. This is from a simulation called Moon Trek, and you can see Gum there, about 55 kilometres in diameter. The crater has collapsed on one side, the rim has collapsed and lava has poured in, so it's quite shallow, which actually makes it very hard to see as well, given its location. He has a satellite crater, Gum S, also named after him. I don't know the rationale behind that. Gum was, I think, named around, approved in 1970 by the International Astronomical Union. the satellite crater, well, I think was approved in 2006. But the satellite crater is easier to see, and and they're all set on the shores of Mare, Australia. How appropriate. And this is a photo I took one night. I just happened to be outside imaging other things, and I thought, hang on, let me check to see if the moon was up. And yes, Gum had sort of crept around. It's really quite a poor photo, but you can see it is actually a very challenging object to photograph. What I have here now is just a reminder of some of the images that, or some of the nebulae that he catalogued. Some have very familiar names, like the Trifid Nebula, et cetera, but they all form part of his catalogue. I'll just run this. This is a video, and it's composed of, and hopefully the sound plays, it's composed of, only runs for a couple of minutes, images from taken by members of the Astronomical Society of South Australia. And hopefully the sound will come up. It starts in about a second. And Gum being used to play the flute, you might hear the flute occasionally through this as well. Listen carefully. All right, so in conclusion, just a few remarks. Colin Stanley Gum clearly made several significant contributions to astronomy, as evidenced in my presentation earlier. His early death was no doubt a huge loss for astronomy in Australia. And he also demonstrated considerable resilience and determination, including innovation, to actually achieve his goals, despite challenges which were both personal and professional in nature. The Gum catalogue of hydrogen alpha emission nebulae contains many of the most popular objects in the Southern Milky Way for today's amateur astronomers and astrophotographers in particular. So there's almost a connection from his professional work into the amateur space now as well, which I think is intriguing. And I think there's a case for a greater public awareness in Australia of Gum's life and achievements, including a new land-based memorial, perhaps a place on Earth. He has a place in the sky, he has a place on the moon, but they're largely out of sight and out of mind. But a place on Earth, I think, would be quite appropriate to remind people of his achievements, given where he came from, given all the challenges he faced and what he achieved. I think it's a really important lesson. Just quickly acknowledge the people on the screen here who contributed to this presentation in one way or another. And if you have any information, further information on Colin Stanley Gum, please feel free to email me. You can do it by just sending an email to gum@skymaps.com. I'll pick it up there as I continue to compile information. And that's my presentation. Thank you.
That's a pretty nifty presentation.
You like it?
Yeah, Gum 12 was my favourite, outside of Triffid.
Oh, which one?
Gum 12.
Oh,
yeah,
really?
yeah, really like it. We do have a couple of questions for you before I jumped into the crowd. Can you ask Dr. Kim, why are hydrogen emission regions helpful to knowing about the structure of the universe?
Structure of galaxies, yeah. Yeah, so the reason is, as I mentioned earlier, astronomers started observing galaxies like the Whirlpool galaxy and the Andromeda galaxy, and they noticed that hydrogen alpha was located along the spiral arms. And because we are located within our galaxy, we can't see our spiral arms. We suspect they were there, and that was the purpose of the work. We're looking into a plane. We can't go on top and look down. So by measuring the location, identifying them and measuring them and mapping them out, you can actually determine the spiral structure. So Gum did the work for the Southern Hemisphere, and there was another guy who did the work in the Northern Hemisphere, and together they mapped out the spiral structure of our galaxy, the Milky Way. That's the reason.
Okay. And the next one is, are there any books on Colin Gum's life and legacy that you're aware of?
No.
There should be.
There are some write-ups. If you go back through the presentation, the NRAO, there are some write-ups about some of his professional work, and his papers are available. And I've provided all the references in the presentation. You can actually go back and find some of this. Yeah.
You might have to write a book on him.
Yeah, I might have to.
You might. Okay, so do we have any questions in the crowd? Any from the audience who's got a question for Kim on Colin Stanley Gum? I think you've bamboozled everybody. Yeah. Well, I'm going to put we do have a question. I was going to put a challenge out, but we'll get a question first.
Just thinking of his photographic techniques, do you know if he happened to cross paths with David Malan and gave him some
This
of
is
the
before
ideas?
Malan. This is well before Malan.
Before.
Well
Thought
before.
it might be before.
Yeah.
There we go. That answered that one. Any other questions? No? All right. I'm going to issue a challenge then I was going to issue it to ASV members, ASV astrophotographers, but I thought, hang on, ASA as well.
Well, actually,
And then I thought, you know what? Any astrophotographer watching, we want to see your Gum images.
yeah. So what the ASA is doing, I sort of inspired them to think about what they could do, and I think they've now committed to creating a catalogue online that's easily accessible, and having our members in ASA, submit photos for all of the actual Gum nebulae.
That's a very cool idea.
Yeah,
I like
it's
that.
a very cool idea.
Yeah,
And
it
I
is.
think having them all in one place and having them done from the Southern Hemisphere,
Yeah.
Australia, I think it's really important.
Well, there you go. I'm going to issue a challenge to astrophotographers. I want to see your Gum Nebula images. We'll share them on the ASV's page. Tag us in Instagram as well. And to our ASV members, Yeah. Clint. Oh, Clint got a question.
Did Gum ever have a family?
Did he have a family?
No, not that I know
No?
of. No, there's no indication anywhere. No.
I think it'd be a pretty good book.
It'd be an
I
interesting
really
book.
do,
I mean,
yeah.
the spreadsheet I've got running on his life at the moment is just
Big.
humongous.
Yeah.
As more data comes in, information comes in, goes in there chronologically, and you start painting out the picture.
Well, you are retired now, so.
I've got plenty of things to do.
All right, there we go. So the challenge is out there for not just ASV members, but astrophotographers who are watching. Tag the ASV in your Gum images. I didn't realize there was 84 of them.
84,
Yeah, quite a lot. So,
I haven't actually personally gone through and double-checked those. I'd love to make my own database and look at the 40 that we knew.
The 40 main ones,
That'd be
yeah.
very interesting,
yeah, it'll be interesting. Oh, well, Kim, thank you very much for
You're
coming
welcome.
over from
Hope you
South
enjoyed
Australia
that.
for us.
Cheers.
Everybody, thank you, Kim. Thank you. It's a wonderful presentation. Sorry?
I'll get off stage.
Yeah, while you get off stage, we'll introduce Bill Stent, the telescope gent, the real one, not the fake one, who's here to give a presentation for what's in the sky
Do you
for
need the podium?
December and January.
Got this here.
Yeah? You ready to go? Shall we? Sorry? Mostly the end of December,
HDMI.
because that's when the good skies are going to be. Hopefully, we're going to have clear skies later this month. I think the most interesting thing is that new moon is going to be pretty much leading into New Year's Eve this year. So that'll be fun. Any targets in particular, Bill, that you're going to be focusing on, other than untangling yourself there?
Good.
You're focusing on domes? Yeah? Who wants to know Bill's password?
Oh, you missed it.
Oh, I was 2284 if you get Bill's laptop. There we go.
Sorry, you
A
want
little bit like my old car.
Yeah? Did you have a club lock without a key?
Normally leave the car open.
Leave the car open,
The
okay.
glove box open like that.
All right, we're getting there. They're just having a little discussion. What's the saying, Lee? If there's no technical issues on an ASV live stream, it's not worth it. We've got to have some technical issues. We're good to go.
I think so.
Yeah?
All right.
The floor is, oh, hang on, you're not quite there yet, Bill.
No.
The floor is almost yours.
Hang on, I haven't got my clicker.
Come on, hurry
I haven't
up.
got my
Get your
clicker.
pointer.
Where's my clicker?
There we go. All right,
There
the
we
floor
go.
is yours,
All
Bill.
right. Let's see. I think it's that button. There you go. All right. First of all, thank you, Kim, for that presentation. It was interesting and unexpectedly emotional. Tonight we're talking about what's in the sky late December to early January 2025. I will talk a little bit because there's no January meeting. I will talk a little bit about after that, but that's basically where we're going. Come on. There we go. Tonight, as always, we're on the lands of the Bunurong and the Wurundjeri Woi-wurrung peoples of the Kulin Nation. I'm going to talk about general conditions at this time of year, mostly about the summer solstice, which is now. And then I'm going to get into the usual what's in the sky, where's the moon, what planets there are, including a little bit of how to find this info, because we're not doing one of these things in January. Then I'll talk about getting orientated, constellations, brass stars, as usual. Suggested targets, visual and photographic, and then I'll talk about some 5 a.m. stuff for the people who want to get out of bed early or the people who've got a baby or a dog. Finally, things to look out for this month. Oh, can we have some lights off, please? One more. We can't turn that one? No, what about that one? Yeah. Because that's going to stuff us up a bit. Can we turn it off? Yeah, put the power back. Oh, this. I have to do it myself. Just I've always been one for doing things the right way. All right, general conditions. I'm going to stand up here. General conditions at this time of year. We are at the minimum darkness now. Summer solstice is on the 21st, obviously. So we're getting close there. We're very close, actually. Because of the shape of the sine wave, we're almost there anyway. Sunset's about 8:30. Dark about an hour later-ish. Next month, it's 8:44, so it's almost no difference. Sunrise is at 5:50 a.m. And next month is going to be about 6:10, so there's a little bit of a difference there. It's because of the shape of the sine wave. The flip side, it's the start of open cluster season. Now, open clusters tend to form around the plane of the Milky Way, and globs tend to hang around the galactic centre. That's what they do. So just to give you an idea of how many clusters there are, there they are. Look at them all. There's a couple of the globs are sort of like there and there and there, and there's a couple up there, but mostly all of this area here is all open clusters. So that's great for visual astronomers like us, or should I say, I've got a foot in both camps, I suppose, but visual astronomers love open clusters, especially the people who do the tours at the thing. Summer solstice, sunset is on the 21st at 8:38 p.m. at azimuth 239.37, so that's around about there, and the sun comes down like that. Due west is, of course, 270, so that's where it is at the equinoxes. Sunrise is on the 22nd is 5:58 at azimuth 120, which is on the other side of the person who took this photograph. Back. Solar coordinates at this time of year are 18 hours exactly. That puts the sun in Sagittarius. Declination is 90 minus the latitude of where you happen to be, the Antarctic Circle, so that's minus 23.26. But by the way, this is the Yuang Solar Observatory. It's what we believe to be the oldest solar observatory on the planet. It's just to give you an idea, Western astronomy has been going for maybe 3,000 years. This is about somewhere between 10 and 20,000 years old, and it's in Lara in south of Melbourne. So it's done by obviously the responsibility of the First Nations, and they did a very good job. As you can see, they nailed the winter solstice. You stand on the stone, which is not in the shot there. Stand there, and you sight along these stones. It's the winter solstice. You sight along those stones, and you see the southern solstice. It's highly accurate. There's also 3 sighting stones down there for the equinoxes. For young astronomers, speaking of the summer solstice, I'm going to ask a question. Why does the sun set to the left of west and rise to the right of east, which is over there, in summer? And does it look the same from the northern hemisphere? And does it do the same in winter? So you young astronomers who are hopefully out there in YouTube land, start scratching your heads. Okay, for the loonies. Let's see. Full moon is on Sunday the 15th, so it's coming up fairly shortly. It's well into the north in this day, so it's going to be low in the sky for another week or so. It's 25% into its distance range, so I'm calling it a meh moon. It's neither a super or a mini moon. It rises, because it's a full moon, it rises at sunset and sets at sunrise, which means that, like this photograph, it's poor viewing because you're not casting any shadows. So it's very flat. It's very boring to take a photograph or watch the moon at full moon. Obviously, it's up all night and over the following week, and it's going as a waning gibbous. The last quarter is just before Christmas. It crosses into the south on the same day, so it's going to start to get high in the sky again. Obviously, on that day, it's going to rise due east. It rises at midnight and sets at noon, and then over the following week as a waning crescent. It's getting smaller and smaller. It'll get thinner and harder to see as it gets closer to the sun as well. And you view it in the morning and later on this week in the early afternoon. Now, the new moon for the astrophotographers is on New Year's Eve, which means it rises at sunset and sets at rises at sunrise and sets at sunset with the sun. It's a waxing crescent. You will be able to see it a couple of days either side of the new moon. It's going to be really, really hard to see it. We saw a great one up at Sea Lake. First quarter, Tuesday the 7th, a week later. It rises at noon, sets at midnight as usual. Best viewing, that's for people who are organising a star party. Then you look at it over the following week as a waxing gibbous. It's going to the north on the 6th, so it's kind of east, and then it'll be low in the sky for the next fortnight. And how do I get this information? This is stuff that I got from JPL, through astropixels.com. It is the proportion illuminated, the lunar distance, the lunar declination, as well as the solar declination. And this gives me all of this information. I'll just quickly run through it because, you know, I do it once every year or so. The phase of the moon is indicated by the dark green line, and obviously the new moon is when the phase is 0. First quarter is 50%, full moon is 100%, and last quarter is when it is 50%, and these are the dates down the bottom. The lunar distance gives you whether or not the moon is going to be big or small. Mini moon is not bad here and here because they're fairly high up. This is very much not a supermoon. It's a moon. It's about 20-25%. That one's absolute garbage. So you wouldn't call it a supermoon there, but I'm sure some media outlet will. The lunar declination is when it goes north and south of our equator, and as you can see, it's north up there, it goes down south, and it's south in there. And solar declination, I've really put that in because, look, there's a summer solstice on the 22nd. So, you put these lines together and you can find eclipses and all sorts of weird stuff. It's very, very handy. So that's that. Okay, planets over the next month. This is mainly from the ASB yearbook. Mercury is going back to a morning object. It changes just about every month. It's buried still in the twilight. You won't be able to see much of it. Venus is still very, very bright. It's magnitude minus 4.3 in the evening. You can probably hear it from here. And it sets very, very late at the moment. It's about maximum, close to maximum elongation at 11:40. Mars is rising at about the same time that Venus sets, sort of just before midnight. It's in retrograde now, and it's going to start to get very bright. Opposition is mid-January. I think it's the 6th. Is that right? I can't remember. This is the best time to observe Mars. So get out those telescopes. You're going to need a telescope with a fairly long focal length because Mars is very small. If you squint, you can see all sorts of detail on it. Jupiter is past opposition, so it's kind of going. It's rising before sunset. It's still bright. But it's in a good place for observation. It's in the open end of the V of the Hyades, but you won't need any signposts because it's the bright thing. If you're looking for the Hyades, it's the V-shaped thing near Jupiter, not the other way around. Saturn is setting just after midnight. It's kind of past its prime. The rings are still closing. It will be past opposition conjunction. When in March of 2025. So that's going to be a very, very interesting time to be looking at Saturn because it's going to be completely naked. You won't see the rings and you won't see a shadow. And at that time, it's also going to be a morning object because it's gone past conjunction. Uranus is setting at about 4 a.m, so it's good for all-night viewing. It's still ahead of Jupiter. It's going to be a little bit harder to find because it's not a very bright object. Look for using a large long telescope, you'll look for a sort of a greeny blue object, not very far from the Pleiades. Neptune is following Saturn, rising and setting about a half an hour after. It's following it, so Saturn comes up, Neptune is after it, and it's a little bit bluer than Uranus. Pluto is a planet, and it's very difficult now. It sets soon after twilight, so it's pretty much gone for the season. Okay, how to get information. Bye. Bye-bye. Oh, well. So, I don't know what happened. I've been eclipsed. So, oh, there you go. Right, so planets, this is how you get the information from the yearbook. Now, I received my yearbook in the post this afternoon. It's just been posted out. I got this a little bit early because, you know, I'm friends with the president, apparently. In the back of the yearbook, you see this weird-looking thing. This shows you rising and setting times for the planets all the way through the year, including the sun. This is the sunrise and the sunset. Actually, that's the sunset there. That's the sunrise there. So you can tell roughly when they rise and set, and that's really very useful little thing. Remember, the times here are Australian Eastern Standard Time, not Australian Eastern Daylight Savings Time. The other thing that you'll find very useful is the monthly pages in the yearbook. This is January and February. You can ignore the squiggly lines there. That's Jupiter's moons, but you'll see the first quarter and mini moons and, you know, bits and pieces like that there. So that's how I get my information, and, you know, apart from other bits and pieces. Yes.
Edge on for Saturn.
Yes.
We also get transits of the moons of Saturn.
Yes.
Anywhere to get that sort of information?
I don't think those ephemerides are in the, or those phenomena are in the yearbook, are
Not
they?
in our yearbook,
Yes.
but is there another place to go?
There will inevitably be another place to go, but Google is your friend. So, but yeah, it'll probably be something like astropixels.com or something. Yeah, yeah. I've never actually seen a transit on Saturn. So, British Astronomy. Thanks, Kim.
Yeah.
Excellent. Ask a question, get an answer from an expert. Getting orientated. I'm somebody who prepares talk. Getting orientated. This is the sky facing south at 10 p.m. So the Southern Cross, one of our signposts, is very close to the bottom. It's about 7 o'clock in that clock. Just get rid of the clock. There it is. Orion is rising in the east. That's our second signpost, and the third signpost is gone. That's Scorpius. So there are three things we look for. For orientation stars, we've got Canopus, which, if you remember the clock face, Canopus leads the Southern Cross around the pole, and Achernar is pretty much, there it is. And Achernar is opposite the cross around the pole. So actually, Achernar and Mimosa, or Achernar and possibly Hadar, is a good way of finding the southern celestial pole, south celestial pole. I don't know why I'm pointing. I've got this thing. And there's Hadar, and there's Achernar, and in the middle is south celestial pole. That's a fairly good way of doing it. Fomalhaut is to the west of the zenith, so it's starting to move off. Sirius is bright and it's lowish in the east, so we're starting to get Orion season. And red Aldebaran is near the V shape. Don't look at Jupiter. Aldebaran is in the V shape of the Hyades asterism on the other side of Orion from Sirius, and don't get it confused with Betelgeuse. So now the planets at this time of night, Jupiter is bright in the east, and then Saturn is still there. It's getting dimmer and it's past the meridian, but it's still there. Venus is extremely bright. And I think that's all we've got for the planets. So there you go. Right, so visual targets for the evening. We've got Venus, obviously. You've got to be fairly quick because it's gonna get down below buildings and trees and stuff like that. Saturn is still there, and now Beta Tucani is a triplet. It's just past the zenith there. It's not quite close for a donut warning, but it's a little bit on the south side. 47 Tuc is also there. That's a great thing to look at if you've got a decent aperture. In a small telescope, it will be just a bit of a blob. P. Eridani, the cat's eye double, which is really nice. That's very close to Achernar. You can see that in your finder scope. If you find Achernar, it's the thing which is right next to it, slightly to the north. Theta Eridani is another double, which is not very far from the zenith. That one gets a donut warning. The Tarantula Nebula is still on the east of the zenith, so it'll be good viewing. You can see that with most types of instruments. You can see that with your naked eye if you know where it is in these in a dark sky site. Pleiades, it's the first time I've mentioned the Pleiades, I think this year. Very wide open cluster. It's hard to get it all in a long telescope. You want this is the place where you want a pair of binoculars or a small telescope. Gamma Arietis is right on the north-south line. What do they call it? Meridian. Thank you. Slight problem there. Yeah, that's a nice double. It's easy to find, although not tonight. The moon's too close. The diamond cluster is the first. I decided to throw in our cluster because it's the start of the cluster season. They're all around there. This one, the diamond cluster, is about the closest to the zenith that I could find, so that's the one I picked. So, and obviously the Great Nebula Orion. It's coming. Everyone likes to see that. It's very nice. Sirius, yes, it's a double. A lot of people don't know it, and it's hard to see, but the companion is really, really small. So, but if you've got a decent telescope, you should be able to spot that. It's a bit of a challenge for you. Obviously, Jupiter is still there, and the last challenge is the poor man's double cluster. They're not great clusters, but you can get two of them in the one field of view. So that's. Oh, another one. Oh yeah, one of my favourites, Southern Alberio, very nicely coloured double. It's still very early. You probably want to wait until midnight or something like that before it comes up. But yeah, that's well worth a shot. So they're the visual targets. Right, photographic targets. This is where I rip off Facebook users unmercifully. So Southern Pinwheel Galaxy. That's Diego's. It's not green enough, Diego. No, he's busy. He's busy with another club tonight, so he's not listening. Triangulum Galaxy, Lee, green. Thank you. It's one of the last chances. It's past the meridian by now, so you won't get very many hours on it. 1365, I think that's Russell's. I can't remember whose that was. I'm sorry. But there's a donut warning on that one because it comes very close to the zenith. So if your telescope can't point straight up, you're going to have a problem. Large Magellanic Cloud and the Tarantula Nebula, easy one to get. This one's from one of the remote observatories. Helix Nebula, as you can see, that's satisfactorily green, so it's my photograph. Pleiades, oh, God, who's that? So he's been begging me for months to put up one of his phone photographs. So there you go. Pleiades M45. You need a wide field. It's a nice shot there, Mark. Got a nice bit of nebulosity. 47 Tuck and the SMC. Great shot there by Jeff Healy. It's a nice telescope. Now, no presentation is complete without an Eddie Pang shot. It will blow your socks off. That is amazing. It's now the Crab Nebula, you're going to have to get onto fairly quickly if you want it because it doesn't stay around for very long. We've only got about 2 or possibly 3 months at the very most, and that's when you're shooting less than about 15 degrees. So it's a hard one to get. Rosette Nebula, it's one of the early ones. That's just hydrogen alpha there. Kim. That's my own shot. That's a 2-pane. Cone Nebula, I think that's Gerald's. Yeah, that's Gerald's photograph. I don't know if he's listening, but hi, Gerald. It's Christmas. He put that up. So I'm stacking him in because this is 2 months worth. The Carina Nebula is a little too early still, but yeah, it's coming. Again, too much green, Bill. Here's the diamond cluster. That's a photograph I took just the other day. Thank you, Elon Musk. That was just a test image. This is 4 shots in RGB, so it's nice. Orion area, obviously, another Diego photograph because it's red and not green. I really like this Barnard's Loop. It's something I've never been able to photograph. I've never had the equipment to be able to do it. But yeah, it's something that boggles my mind. It's nowhere near as big as the Gum Nebula, but it is very, very impressive. Now, around the Orion area, there's the Witch Head, which is Minus's photograph. The Orion Nebula itself is Terry's photograph, and there's the Running Man as well, which is great. That movie's on tonight, I think. And there's obviously the Horsehead Nebula as well, another Mark Escaro photograph. I think it might be a sea star photograph. It's a phone one. Oh, okay, there you go. So, look, I've been too generous. All right, so that's all of that. 5 a.m. tomorrow, you can see the Southern Cross is getting quite high, which means that you'll be able to see all of that nice area in there. That's the Carina Nebula and all that good stuff that's in there. Come on, there you go. Orion is now well past the meridian, but coming up, you'll see Antares and Scorpius. So we've got both of them in the sky at the same time. Early morning planet season is over. You planetoid people will have to stay up late rather than getting earlier. We've got Jupiter and we've got Mercury about to rise. It's going to be very, very hard to get because it's still in twilight. And obviously Mars is past the meridian at 5 a.m. It's moving backwards that way and it's going to be awesome. All right, random observations. The next few days, the Geminids are going. It's a best from the Northern Hemisphere one, but and the radiant is near Castor and Pollux. Now, the cool thing about this is that some of the Geminids go upwards. They go whoop from the so they don't fall, they climb. So look after 2 a.m. and it's north. Obviously, 21st of December is the southern solstice. 25th of Mercury is its greatest elongation, so that's when it climbs out of the twilight. 5th of January, Earth is at perihelion, which does not explain why it gets very warm in January, but it's a good story to start with. The 10th of January, Venus's greatest elongation. It's not actually going to be very significantly different to what it looks like at the moment. It's very, very bright. 13th of January is the closest approach of Mars, and the 16th is opposition, so we're all hoping that Elon's going to disappear. Now, I haven't made a Uranus joke for a while, so Uranus is stationary on the 31st of January. So its retrograde starts. So there you go. Jupiter is stationary and it ends its retrograde, so that's the reason why it's getting dimmer. By the way, Uranus doesn't really change its brightness very much while it's in retrograde because it's just so damn far away. So the 12th of February is the next monthly meeting. So are we having a January one? Let's just get rid of that. So yeah, so that's pretty much it, people. There you go. Oof.
Thank you, Bill. Thank you, Bill. 47 Tuck.
Yeah.
Do you know, I like to use that at demonstrators or at Melbourne Observatory on Monday nights now.
Yes.
To visually find it through the 8-inch dobs in the field. And then explain to people that at a dark sky site, you can go, oh, there it is.
That thing.
Yeah, that thing there. But at Melbourne Observatory, when you look through an 8-inch dob and you go, oh, is that it?
Is that it?
It's a fuzzy little blob.
Yeah. With the trap and things, I don't even bother. You can probably get it okay with the...
With the 12-inch Mercer, we can get it, but it's not great. It's really not great. But it's a great object to explain to people. Second brightest globular cluster in the night sky. And it's hard to see through a telescope in Melbourne.
Mm.
That's what light pollution does to you.
Light pollution sucks.
Thank you for including my Pleiades. I will say it does benefit when you use a mobile phone to use a $10,000 telescope. And it really annoys astrophotographers as well. It's very good at
Excuse me,
doing
my
that.
telescope is ringing.
Yes. So thank you, Bill. That was a wonderful presentation. And we do have a talk in January. I can't remember the date off the top of my head. Pretty sure it's the second Wednesday, 7th. Did I say 7th? I will say check the calendar is what I will say because I can't remember off the top of my head. 8th is, there we go, it's the 8th of January. So that's the second Wednesday.
8th of January.
8th of January.
Well,
You're not on holidays, are you?
I'm doing a dome dome visit from the 11th.
Well, you'll have to beam in you'll be in Lightning Ridge.
I'm in Lightning Ridge.
Yeah, we'll get Bill to beam in from Lightning Ridge. There we go. Yes. So there is a caravan park in Lightning Ridge that has a telescope in it.
There's a 2-metre scope dome, and it's currently been broken into, and
It's fenced off. Is the way to put it.
It's
Now,
not
Colin,
feeling well.
Will the skies clear? So we will open the observatory tonight for those who are here, and we will have a wonderful array of snacks, Christmas snacks. I know there are gingerbread men out there. I'm very excited by that. But we will see everybody again on the 8th of January. We will have a panel discussion headed up by Bruno. He's an ASV member, and we're going to have a panel discussion on cosmology and astrophysics, which we've been trying to organise for a while, but that's what we're going to do next in January. And for those of us who are here, we'll head out now and enjoy some tea and then go out and look through the telescopes at Melbourne Observatory. And for everybody else, we wish you a very Merry Christmas and a Happy New Year. Check the website. We've got some great events, and we will see you in January.